So, I am Latika Swankar and I along with my teammate Diya Gupta are going to demonstrate our project Smart Flood Detector, which will be able to detect flood water that is present in an image. In this project, we have employed KERAS pre-trained MobileNet convolutional deep neural networks and fine-tuned it to predict the probability of flood with the help of those images. So if there is a flood detected from these images, then a tweet will be posted and authorities will be alerted about that area and rescue of the people can be made possible. Now, let's see the working of our project.
First of all, coming to our dataset, we are using an image dataset which is having around 473 images of two categories, of which one is of flooding that like this is of heavy flooding, and other is of normal images. These are some random images, normal images. Now we have divided our data set into three sets, which are test set, train set, and valid set. This train and valid set will be used to train and validate our model, and test set will be used to evaluate our model and find the accuracy. We have used this image data set of flooding and normal images to train our deep learning model. Now coming to our code section. First of all, we have loaded all the required Python libraries like NumPy, TensorFlow, Matplotlib, Keras, sklearn, etc. Then we loaded our data from all the three folders into batches, which are train, test, and valid batches, and pre-processed all the images according to MobileNet requirements. Then we trained our model using these batches and have used 10 epoch for getting optimal results. Now in the graph, as we can see that training accuracy and validation accuracy are colliding at the end of 10th epoch, proving that there is no chance of overfitting and underfitting in our model. And now in the second graph, we can see that the loss has also become negligible at the end of 10th epoch. Then we saved our model for further reference and for deploying it. Then we are plotting a confusion matrix to obtain precision, F1 score, and accuracy of our model. As we can see, we are getting accuracy over 98%, which is quite satisfactory.
Now to evaluate our model, we first load and pre-process the image on which we want to predict and then use model.predict function to get the predictions. Now, coming to the deployment of this model, we have used Flask Python library for this purpose. In the ape.py file, first of all, we have imported all the required Python libraries, and then we have used the same model.predict function on the pre-processed image to see the predictions. And whenever there is a flooding image, then a tweet will be posted, and otherwise no tweet will be posted. We have also made a front end of our model with the help of HTML and CSS. So now let's run this ape.py file to see the functioning of our model. So let's follow this link. So this is the front end of our web service that we have created using HTML and CSS. Now let's choose an image. So when I predict on this image, then it correctly predicts it as a flooding image and a tweet is posted on Twitter. So let's see. So I can see that a tweet is posted on Twitter. Now let's try for another image. So again a tweet is posted on Twitter. But when I choose a non-flooding image, then there is no tweet posted. So we can extend this model by using Raspberry Pi's camera module as a hardware for the purpose of taking images, and then we can predict on those images in the same way as we have done here. So that's all from our side. Thank you.